This is the first chapter of physics from your 10th class, right? So, let's start with the definition of heat. So, if anyone asks you what is the heat, right? So, heat is nothing but it's a form of energy. What? It's a form of energy. So, in this case, if you consider this case, what happens is heat energy flows from body at higher temperature to body at lower temperature. You need to understand one thing. Let's consider a body like this. Let's say this is a block, right? Let's say this is a block of wood. Okay, we'll consider one more block here. Okay, let's say this is a block of iron. Let's say we started heating it. After we started heating it for 30 minutes, let's say, now what happens is the temperature of this block might become 70 degrees centigrade and the temperature of this block might get to 100 degrees centigrade. Now tell me which is higher? According to your observation, which has a higher degree is at higher temperature, right? Now when you put these two blocks in contact with each other, let's say this is block A and this is block B. If you put these two blocks in contact with each other, now I put the block A and block B in contact. Now what happens? The major thing happens is heat, the definition says heat energy flows from body at higher temperature. It flows from body at higher temperature. Let's say B has a temperature of 100 degrees centigrade. So body at higher temperature to body at lower temperature. So heat always flows from body at higher temperature to body at lower temperature. So now if we put these two in contact with each other, what happens is the heat energy might flows from block B to block A, right? So someone might get a doubt, that is, if there is a transfer of heat takes place from B to A, which means 100 to 70. Now what might happens is its overall becomes 0, it becomes 170. Is it right? Because heat is flowing from body at higher temperature to body at lower temperature, right? But it's not true, it is not going to happen here. But in this case what happens is there is a concept, we call it as a thermal equilibrium. We'll deal with it later in our sessions. But in this case what might happens is this is 70 and this is 100. After some time what might happen is it loses 5 degrees centigrade, let's say. What might happen is it comes to 95, that loses 5 degrees centigrade comes to 70 degrees centigrade. So it becomes plus 5, it becomes 75. Let's say, let's lose it 10, it becomes 85 now. Let's add 10 to it, it becomes 85. After those two bodies get the same temperature, right? In the beginning it is at 100, it is at 70. But at last they both come to the same temperature, that is 85 and 85 degrees centigrade. Clear? So that concept we will call it as a thermal equilibrium. In this case we will deal with this later. But here heat energy flows from body at higher temperature to body at lower temperature. In general, I said here heat energy flows, right? But if you go to the previous sessions like 7th and 6th standard, in 7th standard you guys have studied about heat lesson, right? In that lesson this is heat flows in 3 ways. How many ways? Heat flows in 3 ways, right? So those 3 ways were, one is a convection, second one is a conduction. What is it? Conduction. And the third one is radiation. What it is? How many ways? Radiation. 3 ways, right? One is a convection, second one is a conduction, and the third one is a radiation. Coming to the convection, what happens is if you consider a block, let's say, right? A block, let's say it is a solid state. If it is in a solid state, what happens is it contains a particles, right? If you consider the particles were properly arranged like this, right? Okay, let's imagine these as the particles now. These were not the real particles, but just imagine them. Okay, if you consider these particles, normally in solids what happens is there is no space for the particles to move, right? So what might they do is they simply start like this and they simply do only one thing, that is they will be at their position, their mean position, but they do only one thing, that is they tend to vibrate. In solids, motion might be like vibration, right? But if you consider one more kind, that is liquids. If you consider the liquids contains the particles, right? But in liquids, the spaces is quite more than compared to the solids. In solids, there is no space for the particles to move, right? But in liquids, there is a space for the particles to move. So in this case, what happens is the particles might move from one place to the another place, right? There is actual movement of the particles happens here. And if you consider the gases, okay, there is most amount of gap is present for them, so they tend to move much further distances than compared to the liquids also. So if you consider the definition of the convection, there is a transfer of heat takes place from the actual movement of the particles, actual movement of the particles. If there is a transfer of heat energy takes place through actual movement of the particles, we will say it is a convection. If you consider these two cases, in these two cases, that is liquids and gases, what happens is the particles they actually move. But in solids, do they move? No. They are at their mean position, but they tend to vibrate. But in this case, they move from here to there and here to there, might be, right? If you consider the gases, if you consider there is a hydrogen gas, it is talking high, right? And also if you consider oxygen, it moves from here to there, it moves from here to there, right? Yes or no? Right? So gases might move. There is a actual movement of the particles takes place, right? So in gases, there is a transfer of heat takes place, and that thing we will call it as a convection, right? So let me tell you with an example. Let's say if you consider the earth, right? So if you consider the earth, that too at 12 or 1 o'clock afternoon session, that too in summer season, I am talking about the summer season, what might happens is there is a more amount of heat energy here. Yes or no? If you put your legs with bare foot, what might happen? You tend to feel a lot of hotness to your feet, right? Yes? Now, if you consider the air that is present here, if you consider the air here, what might happen is this air gets absorbs the heat energy that's on the land, and then it becomes lighter. Okay, its density becomes lighter. Okay, so normally what happens is the particles having a higher density comes to the bottom, the particles having a lighter density moves to the top. So if you consider the air that is present in the topmost layer, here what might happen is due to the heat energy it gets absorbed, the air density becomes lighter here, and the air density at the top level it becomes heavier than compared to here. What might happen is heavier particles comes down and lighter particles moves up. That is the reason in your room, if you consider your classroom, if you consider, this is the classroom, right? In your classroom there is a ventilation happens, right? So ventilation, if you consider there or somewhere else, right, they will provide us ventilation areas, right? In this case what happens is the hotter air or else the lighter density air moves to the top and escape from those ventilators, right? If that air gets blocked, what might happen? You tend to feel the hot air also, and the room temperature might becomes more. So this is one of the example for convection. And also if you consider one more, if you consider the liquids, let's say if you boil the water, this is the water, right? Now in this case what might happen is if you are increasing the temperature, at the beginning it is at 20 degrees centigrade, after you get it heated for 5 minutes, what might happen is it becomes 20 to 45 or 50, let's say. Now at that position what happens is the particles at the bottom, it absorbs some energy and they becomes lighter, and the particles at the topmost level having a density, their particles having a density that is higher. Now after some time they tend to move. These lighter particles move up and heavier particles comes down. So after it gets 100 degrees centigrade, you tend to see the bubbles, right? Yes, sir? Right? In the hot water, you tend to see the bubbles. That is not happening here. What might happen here is lighter particles moving up and higher particles moving down. That's it. We'll call it as a boiling, right? But in actual boiling, what might happen is lighter particles, they move upward and the denser particles comes downwards, right? In this case, there is actual thing happening here is nothing but a convention. Clear? So heat transfer in how many ways? 3 ways. I think you got to know about the convention now, right? Now we'll move on to the conduction now. Now tell me, what is the convention? Convention is nothing but transfer of heat energy, but through actual movement of the particles. What? Actual movement of the particles, right? So if you look into the next case, that is conduction. Let's say if you look into the conduction now, in this case what might happen is there is also same thing happens here. Transfer of heat energy takes place. In conduction also transfer of heat energy takes place. Okay, wonderful. But in this case what happens is, in the convection there is actual movement, but here there is no actual movement. It doesn't require no actual movement. Without any actual movement, if heat energy transferred, we'll call it as a convection, right? Let me tell you with an example. This only happens in solids. That is nothing but conduction is going to happen in solids. Let me tell you with 1 or 2 examples. Let's say first example is, you tend to know about ironing, right? You tend to iron your shirts, yes or no? Iron your shirts. If you consider, let's say the girls might iron their dresses and women might iron their saris, right? So while ironing, you observe here, this iron box is hotter and the cloth is, it is not hotter, it might be a little bit colder, right? After we rub it, what might happen is there is in this solids, that is iron box, it is made up of iron. Iron is a solid, right? In this, the particles were closely packed, right? So the particles tend to vibrate, right? During the vibration, what happens is it releases the energy, that is heat energy, and that energy transferred to the object that is in contact with this, right? So the shirt gets absorbed that heat energy and it gets ironed, right? So let me tell you one more thing. Let's say if you consider, let's say I know a person, let's call him a Praveen or something else. Okay, let's say we have a Praveen here. So he is good at speaking at phone, right? So he is always calling to his friends and speaking someone else, right? In the meanwhile, while he is at home, he is also talking to his friends, and at that time his mother told him to hold the iron bar. Let's say, you know about the iron bar, right? So he just hold the iron bar, okay, he just hold like this, but he forgot about that thing, right? In the meanwhile, he was just playing with the iron bar, and after some time it gets stuck inside the, let's say, hot stove or something. It gets stuck inside, but he hasn't observed there. But what happens is, after some time, right, after some time what happens is the heat energy that is at this end, right, the heat energy at this end, and after some time what happens is heat energy comes to the iron bar, and that heat energy moves, and after some time he might feel something. What is it? It is nothing but hotness, and now he start to jump like a cat or a dog, maybe, right? Ouch, it hurt, right? He might say like this, right? In this case, what happens here is, if you consider this conduction, right, there is no actual movement of the particles to happen, but heat energy transferred from this side to that side of the object through vibration of the particles. Yes or no? Is there any particle that is at this side comes to this side? No, but it transferred the heat energy, right, through the there is no actual movement of the particles happened, but only the vibration of the particles happened, right? So this process, what do we call it? We call it as a conduction, right? I think you got to know about the convection and the conduction also. Coming to the last and final, we have the radiation. What is it? It is radiation. If you look into this, radiation is nothing but transfer of heat energy by using the electromagnetic waves. What? Using the electromagnetic waves. This heat energy uses the high frequency electromagnetic waves. It is not going to happen in real life situations, but right now we are using, let's say we are using electric oven, right? You know what electric oven? I think you guys know about electric oven, right? While it gets switched on, what happens is there is a heat transfer takes place, right? But there is no contact with it, but heat energy takes place, heat transfer takes place. When you open it, you could feel so much of heat energy comes out of the electric oven, okay? In this electric oven, it releases the electromagnetic waves, right? So those electromagnetic waves tends to move with a higher velocity. We'll call it as, that is 3 into, so 3 into 10 power 5 meter per second, which is nothing but 3 lakhs meters per second. This is the velocity that is equal to light velocity, right? So electromagnetic waves are nothing but light waves as well. So these electromagnetic waves also tend to move with the velocity of light. So that is the reason we could tend to feel more amount of heat energy that is coming out of the electric oven, right? So I think you guys have studied about the convection, conduction and radiation, but in this case if you observe carefully, you tend to read only conduction and convection and conduction, but this is not used for 10th class, but this might be useful in your intermediate, right? But you need to know about this radiation, okay? That's it.